Hello everyone. In the coming 4 videos, we are going to talk about counting techniques. And in this video, we focus on the multiplication rules. When the outcomes of an experiment are equally likely, for example, we flip a coin or we roll a die, the task in computing probabilities simply reduces to counting. Recall the formula in computing the probability of event A occurring. This probability is equal to the number of outcomes leading to event A divided by the total number of outcomes for the experiment, which is equal to NA over NS. The counting technique we are going to go through is the multiplicative rules. We will focus this in this video. And in the next 2 videos, we will talk about permutation and combination respectively. Let's take a look at the first version of the multiplicative rule. If any one of the k different mutually exclusive and collectively exhaustive events that can occur on each of n trials, the number of different possible outcomes is equal to k to the power n. Let's take a look at an illustration. The number of possible outcomes of flipping a coin 4 times is equals to 2 to the power 4, which is equals to 6. When we flip a coin, we can get 2 outcomes. Either we get a head or a tail. So k is equals to 2. And then we flip a coin 4 times. So we are performing 4 trials of an experiment. So n is equals to 4. So the number of possible outcomes of flipping a coin 4 times is equals to 16. Let's take a look at these 16 possible outcomes through a tree diagram. We do the first flip, we get either a head or a tail. And no matter what the result is, when we do the first flip, in the second flip, we can also get a head or a tail. So up till the second flip, we have 4 different outcomes. And then the third flip, again, we can get either a head or a tail. So upon the completion of the third flip, we can get 8 possible outcomes. And then the last flip, we can either get a head or a tail again. So here, the first instance, when all 4 flips are head, we get the outcomes H, 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 H. And the second instance, the first 3 flips are all heads, and the last flip is a tail. So we get H, 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 T. And then the next 2 instances, we get H, H, T, H, and H, H, T, T. Proceed the same way, we can list out all 16 outcomes as shown in the slide. So let's do some calculations here. So the first flip, we get 2 possible outcomes. And the second flip, we have the same 2 possible outcomes, head or tails. The third flip and the fourth flip, we also get 2 possible outcomes. So we simply multiply them together to get the total number of possible outcomes of flipping a coin 4 times. Here, we get 16. Let's take a look at another example. The number of possible outcomes of rolling a 6-sided die 3 times. So when you roll a die, you have 6 different outcomes. The number 1, 2, 3, 4, 5, and 6. So the value of k is equal to 6. And we roll the die 3 times. So n is equal to 3. So the number of possible outcomes is equal to 216. The first row, we get 6 outcomes. The second row, we can have 6 outcomes. And the third row, we can also have 6 outcomes. So multiply them together, we get 216, which is the number of possible outcomes of rolling a 6-sided die 3 times. Let's move on to the multiplicative rule, the second version. Suppose you have k sets of different elements. In the first set, there are altogether n1 number of elements. And then there are n2 number of elements in the second set. And then in the last set, there are altogether nk number of elements in the kth set. Suppose you want to form a sample of k elements by taking one element from each of the k sets. You pick 1 out of n1 in the first set, 1 out of n2 in the second set, until 1 out of nk in the kth set. Then the number of different samples that can be formed is the product n1 times n2 times up to nk. This is the second version of the multiplicative rule. Let's take a look at an example. You go to a restaurant and order a set dinner. You can order 1 soup or salad, 1 main dish, and 1 dessert. And here is the 3-course menu. For soup and salad, you have clam chowder or Caesar salad to choose from. For main dish, you can have BBQ back ribs, chicken burger, or truffle tortellini. For the dessert, you can get cheesecake, chocolate pudding, and gingerbread cake. So the question is, how many different combinations are there to order the set dinner? Here in the menu, we have 3 different sets of elements: the soup and salad, the main dish, and the dessert. For the soup and salad, you have 2 choices. The main dish, you have 3 choices. And for the dessert, you have 3 choices. So by the second version of the multiplicative rule, the number of different combinations to order the set dinner will be 2 times 3 times 3, which is equals to 18. So you can order 18 different combinations with this 3-course menu. Let's take a look at another example. A new car buyer has the choice of 4 body styles, 3 different engines, and 6 colors. In how many ways can a person order one of these cars? Again, by the multiplicative rule, there are 3 different sets of elements in the question: the body styles, the engines, and the colors. So there are 4 body styles, 3 different engines, and 6 different colors. Multiply them together, 4 by 3 by 6. So there are altogether 72 different ways a person can order one of these cars. And that's it for the multiplicative rules. Thank you for watching. And in the next video, we are going to cover permutation. See you.